Yeah. All right. So I made this cheat sheet for us. I am gonna talk about that a little bit later, but I just want to make sure that you guys remind me if I do forget. And then if you guys did see my post about the homework, I did extend this kind of you got to know FRQ homework. I did extend that until tonight. So what I'll kind of do is, if you guys have any pressing questions, we can go over them now. But otherwise, we'll go ahead and wait on that. And kind of go over the answers a little bit more on Monday. Or even what I'll do is I can post the answers, tonight at midnight. And then if you guys have questions on Monday, you can let me know. You can kind of check it on your own. But did you guys have any pressing questions on this? Anything that you were like, I really just didn't get how to do, the table question part, F, for example, or part G. Okay, yeah, I can do that. And oops, I had it on this screen. It wasn't even sharing my screen. Okay. So Elvia said I had answered hers. I know Carlos had a question as well that I can kind of go over quickly. Just other people might So Elvia had asked about so for this question, Elvia was asking about B, and it does say the height of the sand pile. Oops. So it says the height of the sand pile is 40 inches. At t equals 9 minutes. And so Elvia was asking how that kind of played into this right Riemann sum. And so when it says use a right Riemann sum, look at what it's asking us. It's saying just to approximate this integral. So we don't care about the t equals 9 at all. We don't care about any sort of initial at all. All we want to do is approximate this. And then it's saying, what is the meaning of this? Well, the meaning of this guy is not the amount, it's not the right height, but it's the change in the height, right, in whatever units it gives, so in inches, from t equals 0 to t equals 9 minutes. So this integral is simply the change. So we don't add on the initial, we just start doing a right Riemann sum. So, right, we just start with, width is 1, right side is 2. Plus, I'm going to just put dot, dot, dot. You guys can do that on your own. When you would add on the initial is if instead, kind of alternate question, is if instead it says use a right Riemann sum. I'm combining the words right and Riemann sum somehow. Use a right Riemann sum to approximate the height of the sand pit at time 12 minutes. And even harder would be, instead of at time 12 minutes, even harder would actually be at time 0 they could use as well. So I'll kind of look at how we would do both of those. So for at time 12 minutes, well, we know what h of 9 is. Like, that was given to us, right? We know h of 9 equals 40, and we have h prime. That's kind of what we have. So to get from h prime back to h, that's an integral. So we know we can do h of 12 equals h of 9 plus the integral from, now it's 9 to 12, not 0 to 12. So even though we have 0 to 12 on our whole table, our right Riemann sum would only be from 9 to 12 of h prime of t dt. So this would become 40 plus, and now for this, now we do the right Riemann sum. Now in this case, between 9 and 12 only actually has 1 point. So it'd be 3 for our width, and our right side would be 10. And don't just write 30, make sure you're showing that 3 times 10 shows them the point for you understanding a Riemann sum. And so that would become 70. Now, if they had said times 0, right, kind of the same thing, but now we do h of 0 equals h of 9 plus the integral from 9 to 0 of h prime of t dt. And because it's going from 9 to 0, right, we're kind of in here, we're going backwards. Every single one of these values will become flipped, right? It's kind of like on a graph. When it's above, it goes negative. When it's below, it goes positive. Kind of an easier way to do this would probably just be to apply the rule of making this negative and going from 0 to 9 of h prime of t dt, right? That's a little bit easier. So now that we can not have to worry about that and be going the right way. But what's important is this negative sign will go to everything. So what'll happen is this will become 40 minus, and put a big parentheses, and then we'll do the Riemann sum, right? From 0 to 1 is 1 times 2 plus 2 times 5 and 6 times 7. But notice that we need this big parentheses because the negative sign is going to distribute to all 3 of those products, right? Or you can do 40 minus this, minus this, minus this guy. But that's kind of something important. Carlos's question was a little more nuanced. I'll go through it quickly. Carlos was asking about these letters, about like the T letter. So he's saying, well, if we just plugged in 5, right, obviously negative 2 times 5 is negative 10. But then he was saying, well, why is, for this integral, why are we able to use the table even though this is t and dt? And in the table, it has x values. And kind of the explanation for that is that in terms of just switching, right, like with u sub, I think I've told you guys before, if you ever get like you know, a u equals x and the du is just 1 dx, that it doesn't really change anything um, in our final integral. And this is especially true for if it's just x, right? We can actually, it doesn't matter if this variable is t, if it was x, if it was w, if it was z, whatever it is, because it's just one single letter. So if we kind of made u equal to x and du equal to 1 dx, this now becomes negative 10 plus, and we are going to plug in our endpoints, right? When we plug in 5 to x, we still get 5. When we plug in 0 for x, and actually we can't really do u sub, that's my fault, because we don't have an x. So it's kind of like u sub, but instead of u equals t, right, we can do u equals t and du equals 1 dt. But instead of doing u, because we have x, and that's the variable we want, we can actually do u sub, but instead of calling it u, we can call it x. I know it's a little bit funky. So when we plug in 5 for t, x becomes 5 again. When we plug in 0 for t, right, x becomes 0 again. And the t's become x. And so that's why we can use x. Now, do you have to do any of that? Absolutely not. Right? You can just kind of know that it's okay here. We have negative 10 plus, right? And then this guy becomes f of x when we do the integral from 0 to 5. So that becomes negative 10 plus f of 5. You get that value from your table, minus f of 0. You get that value from your table. And it's okay that the variables were t, because we can just understand that they're interchangeable. Now, with the derivative, Elvia is asking about like multiplying by the derivative and whatnot. It's a little bit different, right? With an integral of like f of t dt, this is kind of the same as having f of x dx. You'll get the same answer. But if we have y equals f of x versus y equals f of t, these are totally different. Because if we did the derivative of dt to both sides here, this would become dy dt equals f prime of x times dx dt. And the reason we need to multiply by this dx dt is we have x and we were doing it with respect to dt, they're different. Versus on this side, we would get dy dx equals, but now it's the same variable. So now it's just equal to f prime of t. There's no need for implicit. No, I mean, you could do it, but it would just be dt dt, which is just 1. So you don't really need to do it. But if you're concerned about implicit, you have some like weird different variables, you know, you can always do it and just worry about that. Olivia, I'm not quite 100% sure what you're saying. Can you maybe go on your mic and explain it?
So you know how you were going over like when it's f prime of t from 0 to x, and you technically sub in x for that?
Yeah.
What if it's like x squared? We would multiply, so it'd be like f of x squared times 2x.
So like you have the integral of f prime of, you're saying like in this case t squared?
No, like you know how sometimes well, it's like f prime of t dt, and then it's like 0 to x. And then instead of just x, because you know how normally we'd plug in x, instead of simply x, would it be x squared? Or sorry, what if it's x squared? Would we multiply it by 2x?
Okay, I see what you're saying. No, this is different. Okay, so like if we were just straight doing the integral, right? And this is question H. So let's just kind of do question H. Okay. So if it's simply the integral, we don't need to, because the integral is just the area. So if it's simply on letter H, it says, um, so 0 to x squared of f prime of t dt, right, is equal to n of x. So for n of 3, we literally can just plug in 3 for the x. So 0 to 3 squared is 9 of f prime of t dt, and then by ftc, we get f of 9 minus f of 0. If you want to write it out the long way, integral of f, or f of x from like 0 to 9, you can. But that's -2 minus 5. So we didn't have to do anything at all about multiplying by the x squared. Now, on the flip side, when we're evaluating for n prime, right, which is what the second part asks us to do, before we can do n prime of 3, you always want, and this is something you guys need to work on, you always need to do n prime of x. That's always the first thing you want to do. And this is where you have to do the chain rule. Okay, so that doesn't really have anything to do with the plugging in of the values, because what we kind of did here is we were just saying it's okay to call this x and x. That's okay. Whereas here, you could still call them x and x, but you're plugging in x squared anyways. So for your x, you're plugging in x squared. Here, we're just calling it t. For your t, we're plugging in x squared. So when you plug in x squared, that becomes f of x squared. But because of the chain rule, we need to multiply by the derivative of that, which is 2x. Does that kind of make a little more sense?
Yeah, that was better.
Okay.
Yeah.
Cool. So that's that. Kind of jumping here. I want to go a little bit fast on this. So I'm going to jump over to these FRQ practices. I think these are one of the last ones I do really want to make sure that we get to, because these were the most recent practice exams that were given out. So it says Brandon and Chloe ride their bikes for 4 hours along this flat, straight road. Brandon's velocity is given in miles per hour. It gives us a table, and then Chloe's velocity is given in miles per hour also, but is given by this piecewise function. So I really like this question. I think this is something we could see where they're giving us two velocities, one in a table and one in a piecewise. So the first one says, how many miles did Chloe travel just from time 0 to 2? So when it says how many miles did she travel, that's not quite displacement, but that's change in displacement. So we don't need to worry about any sort of initial. Now in this case, it doesn't actually give us an initial, but had it said, Chloe's time at 0 was actually 10, that wouldn't have mattered because it's just wants to change, right? So to get from velocity, right, because this is a velocity, to get from velocity to miles to position or to change in position, it's just the integral from 0 to 2 of c of t dt. And in this case, 0 to 2 is just fully the top. And you guys have a calculator, so if you had to do this, just type it into your calculator. Technically, yes, it's u sub, u equals 4 minus t squared. Du is -2t dt. So do times -2 times -half. Change your endpoints. 4 minus 0 squared is 4. 4 minus 2 squared is 0. And then we get e to the u du, because the t and the -2 with the dt became du. If you want to flip that back positive, you can. And flip our endpoints. And we'd end up with 1/2 e to the u from 0 to 4. which is 1/2 e to the 4, minus 1/2 e to the 0 is just 1. So that's our answer. Now, had they asked us, and you can add the word miles if you want to. Had they asked us from 0 to say 4 instead, right? Let's say that asked for 4, then it would just be splitting up those integrals. The integral from 0 to 2 of the top plus the integral from 2 to 4 of the bottom. And again, I'm not going to go through this one. This one you would really just type into your calculator. Okay, at time 3, is Chloe's speed increasing or decreasing? I don't have a crystal ball. I really don't know what's going to be on the AP exam. But based on a lot of the mock exams that are floating around, this question has been very popular. This is the speed increasing or decreasing. So the big thing here is just to do V of 3 and A of 3. Just make sure you have those words, and make sure on your A of 3 that you connect it back to V of 3. So A of 3 is V prime of 3. You kind of really need to make sure that you have that written down. And if you want to, even connect it back to the equation. So in this case, it's Chloe, and Chloe's velocity is given by C of 3. So we can say V of 3 is equal to C of 3, which when you plug in 3 is going to be in that bottom section, right? That's where 3 is. So 12 minus 3 times 3 minus 3 squared. We're going to get negative 6, which is less than 0. We want to write that less than 0 as well. Okay. Then for V prime of 3, this is equal to C prime of 3. Now, at 3, it's the bottom. So you don't have to write the full equation. You can just kind of maybe off to the side, just put like C prime of X equals the top part. We don't have to worry about. The bottom part is going to be 12 minus the derivative of 3t is 3. Oh, no, sorry. The 12 goes to 0, right? The derivative of 12 is 0. So the negative 3t goes to negative 3 minus 2t, right? That's between 2 less than t less than 4, I think. Right? And we don't have to do the top. If you want to do the top, you can, but we don't have to because we know we're going in this bottom part. So negative 3 minus 2 times 3 gives us negative 9, which is also less than 0. So we can say the speed is increasing because V of 3 was less than 0 and A of 3 was less than 0. Something, same signs. That's simple enough. Okay. So we really want to make sure we know how to do this one. Alternatively, just in case, if they asked moving towards the origin or away from the origin, it's the exact same question, except instead of V of 3 and A of 3, we would use X of 3 and V of 3. But otherwise, it's the same setup. We check less than 0 or we check greater than 0. But what happens on this guy that's different is on this one, the same sign actually moves away from the origin. I have that in our cheat sheet, so don't feel like you need to fully memorize that right now, but just know that it's the same setup. You have to find X of 3, you have to find V of 3, and check their signs, and then match it to what we know, which is same sign is away, opposite signs are towards. Now, we cannot do that question for this because we don't have a way to find the position at 3, because we have the velocity, and we don't have any initial, right? We would have to have some kind of an initial condition. If they told us that she initially starts at 0, then we could do it. Okay. Is there a time? That's that big hint. That is there a time? Must there be a time? Something like that. That we're doing either IVT or MVT. Possibly that extreme value theorem, but that's a little more obvious where they say where there's a max. Where Brandon's acceleration is 2.5. Okay. So acceleration is the derivative of velocity. So since we have velocity and we want acceleration, we know that that's mvt, right? If it said the velocity and we have velocity, then it's ivt. So between 0 and 4, what I always start off with is literally just doing mvt over 0 and 4 because that's what they gave us. So we can, if we want to, it's nice to just kind of say that B in the STEM, the question instructions, it said that B was differentiable. So therefore, B is continuous over 0 to 4. You're probably not going to lose a point if you don't write that, but it's just nice to show the grader that you understand that before you do MVT. For IVT, you only need to worry about the continuous part. So now what we can do is we can actually just apply MVT. And MVT says that there's some, f prime of c that is equal to, in this case, b of 4 minus b of 0 over 4 minus 0. And using our table, b of 4 is 11 minus 1 over 4. So 10 over 4, which is 2.5. So we can say, yes, by MVT, there must be a time which, or I'm just going to copy what they say, which Brandon's acceleration is 2.5 miles per hour squared during 0 less than t less than 4 hours. It's important that you always put during that interval that you're going with. Okay, so that's that question. While we're at that question, I do want to pop over to this guy, and I don't know, like I said, I don't know if we've fully done this yet, but if you haven't, it's okay. And that's down here. It says, what is the fewest number of times the particle is at rest between 0 and 9? Okay, so this one is pretty important, that kind of fewest times does match up with the same idea of MVT and IVT. So what happens with that is that because it will be MVT, it's sort of also IVT, but what we want to do is, because they're saying V of t equals F of t, okay, and it wants to know when it's at rest. At rest would be that V of t equals to 0. So there are kind of two ways to think of this. We can either think, where does it change direction, right? Or just simply an easier way of doing this is just with IVT. And so with IVT, right, because we have V of t and we want V of t equals 0. So just be careful about that. Like that fewest number at rest would be the same thing. So this would be an IVT because we have V and we have V and we want to know about V equals 0. So you would just simply be looking on this one during this row and figuring out how many times basically does it switch between a positive number to a negative number. There's one that it would have to pass through 0. Here it has to pass through 0. And here it has to pass through 0. So that's kind of a similar one. Okay. Now coming back here. All right, is there a time where Brandon's velocity is equal to Chloe's velocity? This is popular if they give you two velocities. It's a popular thing. Sometimes they even give one that's a velocity and one that's a position. Right, in this case, they're both velocities, miles per hour, but sometimes, like instead, they have C of t is equal to like the position in miles. And if that's the case, then you would need to set C prime equal to B, because C prime would be velocity and B would be velocity. That's not our case here. Our case here, they're both velocities. The tough thing about this is that one of these is a piecewise and one of these um, is a table. So that's what makes it a little bit tougher. But what we can kind of do, and this is what makes this question a little bit hard, is essentially what they're saying is, where is there a time where B of t equals to C of t? But that's really hard to figure out. So what actually happens is we actually are wanting to set B of t minus C of t equal to 0. And that's actually kind of what's going to be a little bit tougher is finding that line here. Okay, and they only said between 0 and 2. So since they only said between 0 and 2, what we want to do is, because it's saying, is there a time? They're not asking us to find the time, they're asking us, is there a time? So that wording tells us that we're probably either doing IVT or MVT. Now, because it says velocity, and these are both given by velocity, we actually want to do IVT. So what that means is we're going to plug in 0, and we're going to plug in 2. So it's recognizing, hey, I'm not actually trying to solve for it. It's saying, is there a time? That's telling me IVT. So we're going to plug in B of 0 minus C of 0. And when we do that, B of 0 is in the table 1. And C of 0 would be, when we plug it in, 0 e to the 4. It doesn't matter. 0 times anything is 0. So we get 1 minus 0, which is 1. Okay, then we're going to plug in 2. B of 2 minus C of 2. On our table, we plug that in. 2 is 1.5. And minus, then for t, right, it would be this guy. I'm going to just write it up here. 2e to the 4 minus 2 squared is 2e to the 0, which is just 2. So 1.5 minus 2, which is negative 0.5. What we can kind of see, and we can maybe write this down to help us out, is that this guy is greater than 0, this guy is less than 0. So by IVT, there must be a time between 0 less than t less than 2 where the velocities are the same, right? Like we can say like B of t minus C of t equals 0, but what that's saying is that their velocities are the same, because that's what they asked us for. Because, right, negative 0.5 is less than B of t minus C of t, which is less than 1. Right? So something like that. And what we may want to add, because we're using IVT, is we might just want to add that B of t and C of t are both continuous from 0 to 2, just so that they know we're thinking about that. Okay, that was definitely a little bit more weird, but we got through it. Now, this last one is implicit, and I really like that because we haven't done a whole lot of these, but it's definitely something that could be asked. And I think that we haven't prepared as much for implicit as we had for everything else. So a lot of times on implicit, they'll give us the derivative. So we're starting here, right? Derivative 2x squared is 4x plus 6y dy dx, right? Anytime we have that, we're going to do dy dx, and then minus. Now we're going to have to use product rule. So right, minus 4xy. I'm going to kind of group the negative 4x together. And what I like to do on these is actually do plus and then group the negative 4x together. So that way I make sure that my negative goes with both. So the derivative of negative 4x is negative 4, leave y alone. And plus, now leave negative 4x alone, derivative of y becomes dy dx equals 0. And the reason I do that with the pluses is just because a lot of times people do the minus on the first one, but not on the second one. And it needs to go to both. So now we're gonna I'm just gonna rewrite this to clean it up a little bit. 4x plus 6y dy dx minus 4y minus 4x dy dx equals 0. And the shortcut tells us that we can move the things without dy dx to the other side and they become negative, or they flip signs. And then our guys with dy dx get divided and they keep their signs. And from here, it's just kind of simplifying, right? So that's equal to, we can divide out by 2. And I'm going to move the y in front because it was positive. So 2y minus 2x over 3y minus 2x. And if you want to be fancy, you can write QED, which is like math term for we proved it. You don't have to write that though. Find the slope of the line tangent to the curve, right? And yes, when we see tangent, we want x1, y1, and m, but we don't necessarily need to do that because it's just saying the slope of the line tangent to the curve at x equals 6. So they just want to know the slope at 6, so they kind of want to know f prime of 6, right? But because dy dx has both x's and y's in it, we actually do need to know both of them. So it is kind of nice to still make the table, but just know they don't want us to write the equation, they just want m. So x is 6, but in order to plug in 6, we also need to plug in our y value. So to get that, we have to go back up to our original. So our original of 2x squared plus, right, 3y squared minus 4xy equals 36. We need to plug in 6 here. So 2 times 6 is 72 plus 3y squared minus 4 times 6 is 24y equals to 36. And you can just use your solve button here. I know this technically was a non-calc question, but for you guys, we have calculators, just use your solve button. You're going to get 2 and 6 both as answers. So what this means is we actually have 2 answers. And so we're going to need to do both of them. So our first answer, right, let's kind of say we can write this as dy dx at 6 comma 2 would equal 2 times 2 is 4 minus 2 times 6 is 12 over 3 times 2 is 6 minus 12. And we get negative 8 over negative 6. That's a valid answer, or we can simplify it to 4/3. Right, that's our first answer. And then dy dx at 6 comma 6 equals, okay, now we're plugging in 6 for both of them. 2 times 6 is 12 minus 12. That's 0 over 18 minus 12. Doesn't matter what the denominator is because the numerator is 0. As long as it's not 0 over 0, we'll go. Then it would have been undefined. So we have 2 slopes, right? And we can kind of go back and make sure it says at each point. That is kind of a hint that there might be more than one answer. So that's that one. C, find the positive value at x where it has a vertical tangent line. So really quick recap, right? Horizontal tangent line means that m equals 0. Vertical tangent line means that m is undefined. And usually what that means is we had some kind of implicit where our slope had a denominator and we're going to set the denominator to 0. So that's kind of a review of this. So I'm going to just go ahead and rewrite our equation up here. So it was 2x squared plus 3y squared minus 4xy equals 36. And our slope, which was 2y minus 2x over 3y minus 2x. I want to write those just so we kind of have them. All right, and so they want to know where do we have a vertical tangent line. So what's going to happen is we can kind of write that we know that kind of because it has a vertical tangent line, that means that 3y minus 2x must equal 0. Right, if you want to kind of write m is undefined, you can write that, right? You can even do like an x1, a y1, and an m where m is undefined. Now, it doesn't say to actually solve for the equations, it just says find the x values. Now, the problem is with 3y minus 2x equal to 0, we cannot just solve that because they're two variables. So we need to go, is there another equation that has x and y in it? Well, there is, and that's this original. So we have 2x squared plus 3y squared minus 4xy equal to 36. And on traditional AP tests, this would be a lot harder because what we would have had to do is solve for one of these, say solve for this guy, and say like y equals 2x over 3, and then plug that in everywhere where we see a y, and then do factoring and solve it, and it just gets really, really nasty. But luckily for us, we do have graphing calculators, and so that makes this question so much easier as long as we know how to use it. So we can go to Menu, Algebra, and Solve System of Equations. We have two equations. The first guy we had was 3y minus 2x equals 0. And the second one was our original 2x squared. There we go. 2x squared plus 3y squared. And then be very careful on your calculator. You cannot type in 4xy. I need us to remember that. We cannot type in 4xy. It treats that as one variable. You have to do minus 4x. Anytime we have an x and a y, we need to do times y, or we'll get it wrong. Equals 36. And then we get these answers now. This is giving us a bunch of answers. And we knew that in here, so we're getting quite a few answers, and that's okay. But what we know is that let's see what it is. Oh, find the positive. Yeah, that's what it was. Find the positive value of x. So if we kind of hit Control Enter, right, it's giving us -3, or it doesn't want to do. There we go. Control Enter. It makes it a little bit easier on us. It's giving us the x and y together. So -7 for x and y equals -4, or positive 7.3 for x and y equals 0.4. So since it just said the positive values, we just want that positive one. Now we can write it this way if we want to. So the or is separating it. So this and was saying this is your x comma your y together. Those are a pair. Or here's your second pair, 3 radical 6 and 2 radical 6. But we don't care about the 2 radical 6. We just care about the x because that's what it wanted. So x equals 3 radical 6. And that's our answer. Okay. The reason for that as well is like, even though you have x equals 3 radical 6, technically you have y equals 3 radical 6. That's where it's happening. When you do y minus y1 equals m times x minus x1, because m is undefined, you can't actually write a full equation. This is the equation. Because if you remember, vertical lines are given by an x equals. So this actually is the equation of the tangent line, is x equals 3 radical 6. All right, and then last one, let x and y be functions of time that are related by 2x squared plus 3y squared minus 4xy equals 36. At time 1, the value of x is 2, the value of y is -2, and the value of dy dt is 4. Find dx dt at time 1. So this is a little bit still implicit, but now instead of doing dy dx, we're doing right with d dt. So when we do our derivative here, we're doing ddt and ddt. So we're going to actually have to redo the derivative, and it's going to become 4x dx dt. Everything's going to get implicit because we're doing it with respect to time, and these are not time. Plus 6y dy dt. And like I said, I'm going to do plus, and I'm going to keep the negative 4x as 1. So negative 4x, right, as 1, and then y as the other thing. Derivative of negative 4x becomes negative 4 because I'm doing the derivative of the x part, dx dt. We're going to leave y alone, right? Y is staying alone because we didn't do a derivative. The x part gets dx dt because we did its derivative. And then plus, now negative 4x is staying alone. The derivative of y is 1 dy dt, right? X doesn't get the implicit because we are leaving it alone. Y gets the implicit, equals 0. And so now that's our equation. We actually don't have to isolate anything, right? We don't have to isolate for x or for y because we're plugging in values. It says at time 1, the value of x is 2 and the value of y is negative 2 and dy dt is 4. And they want us to solve for dx dt. So we're just literally plugging all of those things in. So x was 2, dx dt is what we're trying to figure out. You could call it m if you want to, but I'd probably pick, I'd probably just leave it. Plus 6 times negative 2, and then dy dt was 4. Then I'm going to change this to minus 4 dx dt times y was negative 2. Then again, I'll change this to minus 4 times positive 2 times positive 4 equals 0. And from here, you're just solving, right? 8 dx dt minus 48 plus 8 dx dt minus 32 equals 0. We move the numbers to the other side, right? Negative 48 and negative 32. When we add those, right, become 80. And this is 16 dx dt. And so we get divide by 16, we get dx dt equals 80 over 16, or in your calculator, you can simplify that, and it's 5. So that's different, but it's definitely doable. If you want to review this question, I'm going to post this video and the other video from yesterday, so that we have this entire exam to go through. But there's that. I do still really encourage you guys, and I haven't had time yet. If we have time in tomorrow's session, we can do it. But I really do encourage you guys to go look up the 2019 FRQ. You can literally just, I have it in Google Classroom as well, or you can just type in 2019 AP Calculus FRQ, and it'll come up. One of the links might say, you also get solutions from other teachers. But one of these 2 links will be the questions. So this one is just the questions, and the other link will be the answers. So I really encourage you to do this on your own. I will give you guys extra credit if you solve them on your own, but at least read through them. They're very important. Okay, now what I did really want to get to for today and make sure that we went over is kind of this cheat sheet. I will be posting this for you guys, but I want to talk about it a little bit as well. And that's kind of, I made this cheat sheet. What I did is I went through every problem that I basically thought they could ask, and I kind of didn't write things that I knew either A, we could do on our calculator, or B, we could do by hand, or we should have memorized. Sorry, is what I should say, is that we should have memorized. Now, one thing I do want us to really know is there is this website Symbol Lab. There's also Wolfram Alpha. You don't have a whole lot of time on your AP exam, but at the same time, this can be a very valuable source, but you need to at least show some of your work. So Symbol Lab has a really cool thing that basically is that it can do implicit derivatives. So if we go to solutions and we hit calculus, it can do implicit derivatives. And so it says, do the implicit derivative with dy dx. Let's even see how it handles this dy, kind of maybe even just ddt. I don't know if it'll actually handle this. Of x squared, what was our equation that we just had? Let's see. 2x squared plus 3y squared. Minus 4x. Again, even on Symbolab, you want to make sure that you do times. There's a times button. Y equals 36. And yeah, it's not liking that. So it doesn't want to do the d dt. So you still need to know how to do implicit on your own. But for dy dx, at least, which was part A, it will kind of help us solve that. And it even shows steps. On your phone, it doesn't show steps. You have to do it on a computer. But the other thing it has is if you pop down here to ODE, ODE is differential equations. And so if we hit separable differential equations, I like to hit examples because this will kind of, like if I click on this guy, it'll just format it for me. So this is those questions where we have like dy dx equals something like, say, 3 minus y times 2x, something like that, right? Where we have to put one to the other side. And it'll go ahead and it'll show you that, hey, this is y equals e to the negative x squared minus c1 plus 3. Now, you still need to solve for c, right? But that's pretty cool that it'll help you to check your work like that on some of those things that we're not as familiar with doing on our calculator. So I would encourage you to kind of play around with this. Again, it's this ODE separable, and under derivatives is implicit. I think everything else you'll probably do faster on your calculator, but those two are good to have in our wheelhouse as well. Now, you still need to show the work. You're not going to get any points if you don't show the work. So, you know, that's kind of my spiel about Symbolab. Now, for the Saturday session, I asked you guys about if we wanted to do 8 to 12 or 12 to 4, and it was literally split 6 to 6. You guys are here. What do we think about kind of compromising and just doing it at 10? So that way you guys get to sleep in a little bit, but we're not going all the way till 4 p.m. Okay, so we'll compromise that. So officially our Saturday session will be at 10. And then I did want to just kind of give a little bit of a shout out to some of you guys because what I was saying about this cheat sheet. So I made this one-page cheat sheet, and then I went back and I looked at some of your guys' cheat sheets, and the ones you guys turned in were really, really good. I think some of you guys, I think Monse for sure, Elvia, Sam, maybe Maria, Cassie. I think I actually had stuff on my cheat sheet that was missing that I grabbed from yours. And then a couple that I really liked just because they did things kind of in a unique way. I really like Jackie's a lot, and if you guys don't mind, I'm gonna just show them. So I really like Jackie's, and the reason I like Jackie's a lot is I know it's a little hard to see because it's flipped sideways. See if we can fix that. What Jackie did was she basically, instead of doing a lot of formulas, she did a ton of examples. And I thought that was really cool because examples can really, really help you out. So she basically did all of these examples of things that, here's an example of a Riemann sum, example of a tangent line, example of chain rule, which was really good. Right, and so that's something that can be really helpful. An example of finding all the absolute extrema. I think that's something very, very cool, is to think, hey, on my cheat sheet, why don't I put some examples of questions that I usually have a tough time with? And a lot of you guys did that as well. Another person who did a really good job with the examples, I thought, was Jesus. She had, she had some examples of stuff here. She had the properties of integrals, but then she had an example of one of these related rates, which is cool. And she also, I really like this, and this actually ended up being on the first mock exam, is she had an example of, hey, h of x is 3x. I think there should probably be a plus here. Then I go from 1 to x squared of g of x. What's h prime of x? What's h prime of 2? What's h double prime of x? What's h double prime of 2? And this is a great, great, great question to have as an example on your cheat sheet, because that's something that is tough that you can't do with a calculator. So that's an awesome one. She had an example of one of these like m of x equals f of x cubed things as well, which is another good one to have. So I thought that was cool. I also thought Kate had a really good example that she put in here um, of MVT with this table. And so she had this question, is there a C in the closed interval such that G prime of C equals -4? So this was probably a question that she had struggled with or that she wanted extra help with. And she put that in there. I think that's a great, great example to have as well. And so I wanted to kind of show those. And then in addition, another person who had good examples, but kind of in a different way, and it wasn't quite example questions. Maria had these graphs here, right? So she was showing these graphs of, F prime graph, F double prime graph, and how they relate. We did that in class. I think Kyra did something similar with the chart that we did in class about how those relate. So that was cool. And the other thing that I don't want to overstate is, which can be helpful and cool, is I just liked, Monse said, remember to be confident, you got this, and kind of notes for herself. Like remember to always read questions carefully, and if you don't understand them, to skip them. A lot of you guys did this too, so it wasn't just her. I think Cassie had some similar stuff. But all of you guys who did it, if I didn't show yours, it was all of yours were great. Some of you guys had some really good coloring going on too. Elvia's was really, she called it the cool cheat sheet. Yeah, so Cassie wrote some reminders to herself as well. So just anything that you think is going to help you. Okay. Now, here's kind of what I would recommend. Is I would recommend on the exam not trying to have too much. You don't want to have to be going through your notebook and trying to find something that you don't know what page it's on. It's not going to help. So this file here, the only issue with it is I tried to fit so much in that you really have to zoom in to read some of it. If you have a printer, you could try printing it and seeing if it's readable. I don't know if some of these small things will be. But you definitely don't want to have this on your phone if you're turning the test in on your phone. So if you have a Chromebook, you want to have this open on the Chromebook where you can kind of zoom in and zoom out. So I kind of did these theorems, right? Must there be a value? I talked about MVT, which is when you're looking for a value of the function, the derivative, and you're given the function, and then there's our formula. IVT, you're looking for a value of the function, and it's given. Extreme value theorem. Second derivative test is something we're not always as familiar with, right? I didn't put how to do derivatives. I didn't put how to find increasing, decreasing intervals, max, min, like concave up, concave down, because I feel like we're really good at that. But I did put second derivative test because it's a little less common. Approximations, these are all of the, right Riemann sum, left Riemann sum, trap, tangent line, whether it's over or under. For max min, just remember you need to write f prime to 0 to get that point, and make a table or do a number line if it's absolute or relative. For graph of derivatives, here's a bunch of things. I'm not going to read through all of those here. I think you can do that on your own. A bunch of differentiation rules, chain rule, product rule, quotient rule. Make sure we're careful with our parentheses on these, right? Like for f of x and g of x here, we would want to make sure that they're both in their own parentheses, right? Same thing with quotient rule. G of x is in its own parentheses. F prime of x is its own parentheses. Implicit, I put a little example here as well. I did an example with DDT since they're both going to get implicit. Definition of the derivative, just in case. Okay, it hasn't shown up on any mock exams, but just in case this weird limit thing with h's or this shows up, that's definition of the derivative, right? If it shows that, f of like sine of x plus h minus sine of x over h, the answer is just cosine. You're just taking the derivative. Okay. L'Hopital's rule, 0 over 0, technically infinity over infinity. There's how to do it. And then just this note about if it says the limit can be evaluated with L'Hopital's rule, you might need to set the limit of the numerator and the denominator equal to 0 separately. That mock exam had that they went over. Okay, FTC, both types of FTC, right? Be careful with the use of. Here's an example with f prime 2x, and then the derivative part of FTC, and then this a of x, b of x thing is just if it's not x, right? And even if you have one in the denominator, so if you have like x squared and 2x, you have to do the chain rule, and it would be the top part minus the bottom part. Okay. So averages, I won't go through those, the two average formulas, what to look out for. Motion, everything to look out for motion. I did do this traveling towards the origin, traveling away from the origin, speed increasing, speed decreasing, total distance, the formula for like x at some time. Integral properties, I threw this integral definition on there just because it did show up on that exam. The b minus a is, right, like on the one that I posted, I think a was 2 and b minus a was 5, right? But a is not 2, a is 2, but b is not 5, b is 7, because whatever gets here, you have to make sure that we remember whatever is in this b minus a, right, is not b. You have to add that number with the lower limit to get the upper limit. So if you're confused about that one, the Khan Academy video I did does a really good job of explaining it. Our other integral properties, right, splitting them up, 0. Tangent lines, we just kind of talked about that vertical tangent line. What we do is set the denominator to 0. Rate in, rate out stuff. The amount entered versus the total amount formulas. Max and min, set R in minus R out to 0. Make a table. And then this is important to realize. If it says, is the amount increasing or decreasing, we do R in minus R out, the total rate, and check if it's positive or negative, because it already is the derivative. But if it asks, is the rate increasing or decreasing, then we actually need to do R prime minus like the derivative of those rates, right? Because it's saying, is the rate increasing? And then our steps for differential equations. So my recommendation to you guys would be, if you like this file, one of two things. Either just use it as is, or what will really help you to really make sure you learn it and you know where everything is rewrite it on a piece of paper. That way it's big enough for you, and you kind of learn it as you go, or you review it as you go. That could be a good idea. But maybe use this as like your cheat sheet number 1. And then maybe a cheat sheet number 2, if you want to, is just put a couple of like the questions that you know that you really want help on, that you think like, hey, if this comes up, I want to have an example of how to do it, right? So those ones that I was showing, like in the beginning, Jackie, Jesus, Kate, where they had those good examples of questions, right? Just have a couple example questions, and that's something that you can have on your exam. That way it's like, hey, I see this, I know this is exactly like this one I wrote down in my cheat sheet. I don't have to go looking for it, it's right there. Okay. So that's all I've got for today. What I'm going to kind of do is, we have the 2 mock exams at 10 a.m. tomorrow. So if I extended the time on yesterday's homework until tonight, so you can work on that today, I will kind of post maybe a couple extra practice questions after the mock exam for you guys to work on Sunday if you want to, but it'll be more optional because I know some of you guys have the AP Gov test on Monday. So this weekend is kind of, hopefully we've hit mostly everything we can. There is a final AP YouTube video at 11 a.m. If you guys want to watch that, I'd recommend it, but I'm not going to require you to watch it. I think it's probably really useful if you can watch it. But really for homework tonight is just finish yesterday's homework, and maybe just study however you want to study for tomorrow's mock exams. Whether it's rewriting this cheat sheet, updating your old cheat sheet, just making a little list of example questions, however you want to do it, is great. Okay. The thing about a cheat sheet is you don't want it to be so big that you can't find stuff. It should be short enough, and it shouldn't have things that you know how to do for sure. Okay, so if you want to rewrite this but just get rid of stuff that you're like, I've got that, like I don't need to have that, then you can rewrite this but not rewrite everything. Okay. Um, that's it for today's session. Thank you guys. We'll meet at 10 a.m. tomorrow to do our mock exams.
You're real quick.
Yeah.
I think you only changed the deadline, like the time, for the video corrections things, not the actual FRQ one.
Okay, I'll change them both so that no one gets it marked as late. I'll change them both.
Okay.
Okay, thank you. All right, bye guys.